Okay, folks, so reading a topographic map is a really important part to be a savvy backcountry traveler. It becomes a really important tool for rescue, knowing where you are to communicate that to others, and also to make sure that you know where you are to be able to go and get the goods, good skiing and riding, and a good access point to get in and out. So we're going to talk about a few things on a topographic map here, and then we're going to spend some time translating that to an electronic version. So first we're going to talk about the scale. So I've got a USGS, United States Geological Survey map here, and these maps are 7.5 minutes of latitude. So on these maps, our scale is 1 to 24,000. So that means that 1 inch on the map equals 24,000 inches in real life. So whenever you're looking at a topographic map, you're going to want to start by looking at the scale. That gives you a sense on how big this map is in real life. All this map is trying to do is translate our three-dimensional world to 2D, and the scale that we're looking at is really important to do that. Next up, we can look at the declination. So every map has one of these, and it's going to show an image here from the difference between geographic north, GN, and magnetic north. Magnetic north is MN on this map. That does change over time, so it's important to take a look at your map and see when it was printed, or if we're using an electronic mapping service like CalTopo that we'll show you later, that automatically updates for the most up-to-date version. That difference becomes important when we use a compass. If you're out there buying a compass, you want to look for a compass that you can set your magnetic declination. You'll notice that on this compass, that N, I've spun this bezel so that the N is facing towards the top of the compass, and this red area here is facing just slightly to the right. It's going to match this image that I've showed you here to represent the difference between geographic north and magnetic north. If you're interested in finding out a little bit more about declination and how it impacts navigation, you can take a look at some of the links that we're going to provide for you in the course, or you can take, there's a whole ACT course specifically focused on orienteering and navigation. So a map and compass is going to be an essential tool for every backcountry traveler if you're really serious about getting into the backcountry. Our BCA slope meters have a miniature compass on it, and it gives us a decent idea of generally which direction we're going, but it is not accurate. It does not include any adjustment for declination, and it's also just not a finely calibrated instrument. So take the information you gather from that little miniature compass with a grain of salt. Awesome, so this map is from the Sawtooth National Recreation Area down in Idaho, and I'm just using it as a way to illustrate the colors on our topographic maps. So we notice we've got a few different primary colors. We've got white here, we've got green here, and we've got blue here. So those are fairly common sense coloring. Blue is obviously going to represent water. So we've got a lake or pond, and then you'll notice that there's a small stream or creek that comes off from that. So that's what the blue is representing on these. Green is representing forested areas, so any area that is primarily forested. And white is representing primarily alpine areas or non-forested. So you'll notice that this X here marks a summit, and as you get higher up in elevation, there's less forested area. Okay, so now we're switching over to a map that's been printed off of the website CalTopo, which we'll be using quite a bit during this course. And you'll notice that this and every other map has that same magnetic north, geographic north declination sign. And this just shows that there's a difference of 11 degrees. So if we were setting that on our compass, we could adjust that. And otherwise, we just know that that's the variation between those two. It's important to note that on every map, the top of the map relates to true north, geographic north. The next thing we're going to focus on is contour lines, or how to tell elevation from the map. On this map, we zoomed in a little bit, so we're seeing a closer look. And this is actually an area that we're going to be using on our course off of Bridger Bowl ski area. So first thing we want to focus on is these thick contour lines. And this is called a primary contour line. It's a little bit thicker in shading, thicker line, and it's got a number here. In this case, you can see 7,400, 7,400. That's an elevation in feet. This map is produced in the US, so we're showing elevations in feet. If you went to Canada or Europe, you'd be showing it in meters. So we jump down to maybe we jump up to our next contour line, it'll read 7,600. So that difference between primary contour lines on a USGS map is typically 200 feet. You'll want to double check. That means that we have these secondary contour lines in between. There's 5 of them, or 5 jumps. Each of them is 40 feet. One important thing to note is if you have a 39-foot cliff, it's not going to show up on a USGS map. It's going to be just under what this map can read. We see our contour lines curving, and we'll spend a little bit more time trying to decipher that. And that's something that comes with a lot of practice. Translating this back into 3D does take time and a lot of practice. So having a map out into the field and translating it with what you're seeing in real life is very, very handy. Last thing I want to call out on this map is the slope angle shading. I'll show you how to turn that on to a map. But here you'll see that there's a darker shading where those contour lines are closer together, and lighter color shading where those contour lines are further apart. So all this software is doing is taking that data, showing how far those contour lines are apart, and coding it until it comes up with a color. So that just is giving you a slope angle reading and applying it to this entire map so that we can see things a little bit easier. Important to note that that's not exact. So everything comes down to using our eyes when we're in the field and using our tools to measure those slope angles. But it can be a great tool to start touring or start planning our tour to see where things get a little bit steeper. Or in this case, we've drawn a purple line on the map kind of outside of all of the shading. So we've tried to isolate our skin track, our way up, completely out of avalanche terrain and avoiding any shading, so we're not even getting close to our 30-degree mark for when we're entering into avalanche terrain. Last thing that we'll mention while we're looking at this map right here is the lack of shading on the ridge line. So that means that that's a flatter section. So it's designating the top of the ridge there. And if you think about looking up at the ridge at Bridger Bowl, that's what you're looking at. You notice that lots of dark coloring here, even some like almost close to black coloring over here. That's designating some cliff bands, some very, very steep chutes that could absolutely be avalanche terrain that we'll want to look out for in terms of what they call overhead hazard. So we don't want to be skinning right below that steep area without having our head on a swivel and looking up to see what sort of exposure we have ahead of us. So one of the hardest things about reading topographic maps is deciphering between a ridgeline and a valley. So we've got a great tool here to help us understand how those shapes work. So in this case, we've got a series of ridges and valleys that lead up towards a summit up here. So you can either start from that summit or start your way down at the bottom. But in this case, I'm going to start drawing our contour lines down this mountain. And it's going to take us all the way down this ridgeline. Remember, if these contour lines are closer together, it's going to mean that it's steeper. And notice I'm trying to make these contour lines actually get a little further apart to signify that it would be a little bit shallower or less steep as you go further down the mountain. So that obviously means that over here in the valley, we're going to have a shape going the other direction. So everything connects on the mountain. So another way to think about this is to see a V or a U shape for either a steeper or shallower ridge or valley. And the closed end of that U or a V is facing uphill if it's a gully or a ravine, and the closed end of that U or V is facing downslope if it's a ridgeline. Ridgelines are where we want to try and find our up tracks so that we can stay out of avalanche terrain and take the lowest angle approach to the top of the mountain.